Hi guys, this is lesson 4.7. It's called inverse linear functions. And in this lesson, we're going to see how to create an inverse. And to do that, we're just going to be switching the x and the y. It's literally going to be changing y for x and x for y. And we are going to be using a different notation. So when we had our original function f of x, our new inverse function is going to be notated like this with this little -1. We just call that an inverse function. We say the inverse function of x. So let's look at an example. So let's say I have an equation for changing Fahrenheit temperature into Celsius temperature. So all my x values are Fahrenheit temperature, degrees Fahrenheit. And so I plug that in for x, that's called an input. And then I do the math over here on the right. And what comes out of it are my y values. And my y values are degrees Celsius. That's called the output. So functions are little math machines. These equations are machines that do something. And this little machine actually, when you use this part of the machine, when you plug in a Fahrenheit value, the machine turns that value into a Celsius temperature instead of a Fahrenheit temperature. So we're going to create an inverse function, and in our inverse function, what's going to happen is our new x values are going to be degrees Celsius, and that's going to be the new input. And then we're going to have new output that's going to be degrees Fahrenheit. So it's really pretty simple what we're going to do here. I'm going to keep that equation where I can see it. What we're going to do is we're going to rewrite this equation and just say y equals 5/9 times x minus 32, because it's a little easier to deal with y than c of x. And then here's the critical next step. We are just going to switch the places of the x and the y. So that's sort of the big how to, what to do for this lesson is you're going to just trade places with the x and the y. So everything else will stay the same here. And the next step is to solve this so that y is by itself. So to do that, I want to get rid of 5/9 here. So I'm actually going to multiply. There's not really room to write it close to the 5/9, but I'm just going to multiply this side of the equation by 9/5, because remember, not 5/9 times 9/5. We're just going to have canceling going on. That's going to equal 1. In order to do that, remember, I have to do it to both sides. And so I'm going to end up with 9/5 x equals y minus 32. Okay, one more step. I need to get y by itself, so I'm going to add 32 to both sides. And I'm going to get 9/5 x plus 32 equals y. So now I have an equation where x is when you put in your Celsius temperature, and y is where you output your Fahrenheit temperature. And so I'm going to rewrite this, and I'm going to call this the inverse function of c equals 9/5 x plus 32. So there are some simpler problems that you'll see. You might see a problem like this, where you see a set of numbers or a table of values, and you have x and y values. I'm making this up, it's no particular pattern. and it asks you to show the inverse function. If you're going to show the inverse function of this, you just copy it and you just put the y's where the x's are and the x's where the y's were. Really simple. You're just changing the places, swapping them around. Okay. Then you will probably have some problems that ask you to find the inverse of a function, and it might be something as simple as this. And you have to find the inverse. And so what you're going to do is just think about y equals 4x minus 8. And then you're going to do the swap. You're going to say x equals 4y minus 8. And then you're going to do some algebra to get y by itself. X plus 8 equals 4y. And then we're going to divide by 4 to get y by itself. Remember that when you divide by 4, it's each part of this divided by 4. So 1 over 4 is actually 1/4 x. We can write it that way. Plus 8 over 4 is 2 equals y. So now I've created the inverse. So I can actually rewrite this with fancy notation. Inverse function of x equals 1/4 x plus 2. So let me show you. I'll see if I have time on this video to go this far. I'm going to do number 32 on page 269 because it involves some of the other skills from the chapter. And number 32 says that the slope of f of x is 7. And it says that the graph of the inverse function contains the point 13 and 1. And we are supposed to write an equation for the inverse function. So let's talk about the original function first. If the slope of our function is 7, then we need to know something else to write an equation, right? Well, we do know something else, but about the inverse. So if I know that this point exists in the inverse, then the point that does exist in my original equation is this one. See, I just swapped the x and the y around it. So now I can use the point slope to write an equation. So I'm going to say y minus 13 equals 7, slope is 7, times x minus 1. And that's an equation that works for my original. This is the original. We want to write the inverse. So what we're going to do is we're going to swap the x and the y. We're going to say x minus 13 equals 7 times y minus 1, and then we're going to do the algebra work to get y by itself. So first thing I'm going to do is get rid of that 7 outside the parentheses by dividing by 7. And then be careful when you have these situations. We just have to do a little rewriting. This is 1/7 x minus 13 over 7. So see, that 7 has to go on the bottom of each piece. And that equals y minus 1. So I need to add 1 to get y all by itself. And I'm going to have 1/7 x. Then I need to add 1 in my calculator, isn't handy. So 1 is the same as 7 over 7. And that is minus 13/7. So we know that is plus a negative. And I'm doing this math right. So I have negative 6/7 minus 6/7 equals y. Last step is just to be official and rewrite this with our function, inverse function notation. The inverse function of x equals 1/7 x minus 6/7. And we are done with that problem. We have accomplished what they ask us to do. So what you need to remember about this, inverse functions are not mysterious. We're just going to swap the x and swap the y because we want the input to become the output and the output to become the input. So we're just switching the place of the x and the y. Really quick, I'll show you what this looks like on a graph. These equations actually become reflections. You'll learn about that more in geometry. Over this diagonal line that is green, here it is y equals x, and I've pre-typed in 2 inverses for you. So this red line right here has an inverse that is the blue line. So see, they're kind of nifty and they reflect over the green line. They're exact inverses of each other. So whatever was x on the red line is now y on the blue line, and whatever was y on the red line is now x on the blue line. Let me get rid of those and I'll show you one more that looks like this. So the purple line has an inverse that is the black line, and these guys happen to reflect exactly parallel over the y equals x line, but they do that because everything that was purple x is now black y, and everything that was purple y is now black x. They're just completely flip-flopped like that. So go to the Alex assignment and work on that and see how that goes, and send me any questions that you still have.